This is my and Wuyi's unit circle project. What is a unit circle? A unit circle is a circle used for reference when measuring angles. The radius of a unit circle will always be 1, meaning that its circumference will always be 2 pi. The angle measure of one complete rotation of a circle will also always be 360 as it is for all circles. Measurements on the unit circle. On the unit circle, angles may either be measured in radians or degrees. Radians are measured by how many radians along the circumference an angle measure is. Radians may either be measured in pi or in decimal form. Angles on a unit circle may also be measured in degrees, which is the measurement of an angle on a plane, which is defined by its full rotation equaling 360 degrees.
How to write an angle in standard position. As previously described, an angle can be written in two different ways, degrees and radians. When graphing an angle in standard position using degrees, you would draw the base of the angle on the x-axis on the right side of the y-axis. Then you would draw the other leg of the angle according to the degree of the particular angle. This angle can be constructed using a protractor. To graph an angle in standard position using radians, you would take the radian, for example 3.18, and graph where the start of the angle is where 3.18 lies. Both measurements will result in angles, and you can graph both of them in positive/negative radians or degrees. To graph a positive measurement, you would go counterclockwise, and to graph a negative measurement, you would graph it clockwise.
The difference between the pi and decimal form of radians. Pi radians. The pi form of radians is in correlation with how far along the circumference of the circle that the angle is. It would be measured in relation to how much of the full 2 pi radians circumference the angle completes. An example of this could be at 180 degrees, where it would be measured in radians as pi radians. This is because it is half of 2 pi, as 180 degrees is half of the 360 degree full rotation. Decimal form. The decimal form of radians is in reference to how many radius lengths around the circumference of the circle the angle is. The amount of radians in decimal form of a full rotation of a circle is approximately 6.28.
How do you calculate the pi form of radians? The pi form of radians is calculated using the circumference formula and in reference to how far along an angle is across the circumference. Knowing that the radius of a unit circle is 1, we know that one full circumference of a unit circle is 2 pi. We also know that the full rotation of any circle is 360 degrees. Using this information, you can determine the radian or degree measure of an angle with prior knowledge of another. Furthermore, we can use the ratio 180 over pi or pi over 180 to solve for either radians or degrees. For example, if the angle measurement is 30 degrees, you multiply 30 by pi and then divide it by 180. If you leave it as a fraction, you would get the radian in terms of pi, or you can divide it fully and get a decimal answer for radians. Different ways the unit circle is broken up. The first way the unit circle is broken up is by 30 degrees. The unit circle is broken up by 4 quadrants, and in those 4 quadrants, the angles are split even further into 3 parts. The 3 angles in each quadrant are spaced apart in intervals of 30 degrees. For example, in quadrant 1, the unit circle is split from 30 degrees to 60 and to 90. This pattern is repeated in the other quadrants as well. That results in a unit circle that is broken up into 12 parts. The next way the unit circle is broken up is by 45 degrees. When the unit circle is broken apart by 8 angles, the angle measurement is between each one is at 45 degrees. In other words, when each quadrant is split in half, the unit circle is split into 45 degrees because half of 90 is 45. The resulting circle will be broken apart by 8 sections of 45 degrees. Lastly, the next way the unit circle can be broken up is by 60 degrees. The unit circle is broken apart in 6 ways. Each section is 60 degrees away from the x-axis, and whenever you add or subtract 60 degrees to the previous angle, you end up with 6 angles that equal full rotations. The resulting figure would depict a circle that is broken up by 6 sections in 60-degree intervals.
Quadrantal angles. The quadrantal angles are those that represent the splitting of the four quadrants. They lie on the x and y axes. These angle measures in degrees consist of 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. In radians, they are 0 or 0 pi radians, pi over 2 radians, pi radians, 3 pi over 2 radians, or 2 pi radians. What the intersections on the unit circle mean. The intersections on the unit circle most simply indicate where the radius meets the circumference of the circle. However, the values at which the intersections occur are significant to finding the trigonometric values. The x value is the cosine value, the y value is the sine value, and the quotient of the two is the tangent value. How right triangles are used to find the points on the unit circle. Right triangles may be used to find a point on the unit circle. This can be done as we know the radius of the unit circle will always be 1, this value being the hypotenuse of the triangle. We can then use any given or known information to solve for the missing value using the Pythagorean theorem. The radius will represent the hypotenuse, which will always be 1, and sine will be opposite of theta, and cosine is adjacent to theta, like depicted to the right.
In conclusion, the unit circle is a vital resource to evaluating not only the angle measurements, but also their trigonometric values.